Hi folks, welcome back. I hope you're all doing well. So on this channel, I've spent a fair amount of time looking at how AI and LLMs in particular are going to affect programming and the teaching of programming and the learning of programming. We've looked at how LLMs like Copilot and Codex are going to affect introductory programming courses, even more advanced programming courses, and questions like how computer science instructors and teachers are trying to change their methods of teaching and their curricula to deal with these new LLMs being so good, particularly at intro-level programming. The paper I'm looking at today was interesting because it tries to ask a more general question. How do LLMs affect knowledge work in general? And the authors here have set up what looks like a very realistic task and realistic experiment to measure the impact of LLMs on everyday knowledge work. This is a pretty long paper. I'd encourage you to read the whole thing. There's a lot of detail. It's very well written and accessible. I'm going to pick out the few highlights that stood out to me. Now, the reason I called it realistic was because they actually performed this experiment on consultants from the Boston Consulting Group. And they gave them tasks that would be pretty typical for a business consultant and then did some measurements on the performance on those tasks, both with and without assistance from GPT-4. They did the experiment with two kinds of tasks. The first one they called outside the frontier, and what they mean by that is a task that they think is just slightly beyond the capabilities of LLMs today. And the experiment task for outside the frontier was to look at an imaginary company's performance on 3 brands and try to uncover some issues. They were given interviews, they were given spreadsheets with financial data, and the goal was to prepare a report for the CEO which explains which brand they should focus on and why, what is the rationale for this choice. So this sounds like pretty run-of-the-mill business consultant stuff. The second task was what the authors call inside the frontier, which means they thought this was just within the capabilities of LLMs today. And the experiment task for inside the frontier was mostly an idea generation task. You have to come up with an idea for a new product for a footwear company. And so the task is to generate new ideas, pick the best idea and why it was the best one, describe a prototype, come up with steps needed to launch the product. So the full gamut of what it takes to come up with an idea for a new product and then write out how you would actually go about developing that new product. So those were the tasks, and I thought this setup was really compelling because you're not looking at volunteers, you're not looking at grad students or people on Mechanical Turk. These are real consultants in a real consulting company. All right, there's a lot of really interesting nuance and discussion in the paper, but let me jump right to the headline results. This graph shows the performance of the consultants on these tasks under 3 conditions. The control condition, which is this blue graph, is when they perform these tasks without any AI assistance at all. The green and blue distributions show performance on the task with AI assistance. The only difference is that the red graph, which says GPT plus overview, was for a group that got a quick primer on prompt engineering for how to build and craft effective prompts for GPT-4. Whereas the green group, the group that says GPT only, were just thrown into it without any instruction on what makes for a good prompt. They just had to learn it as they went along. On the x-axis, we have quality as judged by human raters, and the density or the frequency is on the y-axis. And here you can see a very clear separation. the group that got AI assistance, whether it was with or without a prompt engineering primer, clearly performs noticeably better than the group without AI assistance. This is a different look at the same question. Here they're performing regression on the 18 questions that were sub-questions within that task, and the control condition is without AI, and the treatment condition is with AI. And you can see in pretty much all measurements, the score under the treatment condition, which is with AI, is noticeably higher than the control condition without AI. Now, this graph is really interesting. If you break up your population by skill and you look at the bottom half of your participants by skill, you'll see that they get a 43% bump by using AI assistance. On the other hand, the top half of the population also sees a bump from using AI assistance, but they see a much smaller bump. They see about a 17% increase. So it looks like one big effect of AI assistance is to bring the floor up. It helps the bottom half much more than your more talented, more capable performers. All right, so those were the numbers for the simpler task, the one that was inside the frontier. If you look at the task that was more challenging, the one they called outside the frontier, the picture changes. This shows the performance of the participants that used Gen AI was lower than the control condition, the ones that didn't use it. But the interesting thing is that even though the overall recommendation was incorrect, if you look at just the quality of the recommendation was higher for those that used AI assistance. This graph on the left shows the difference for the subjects that got it right, that got the recommendation right, and this one on the right shows the difference for the subjects that got it wrong. And in both cases, the quality of the recommendation was better. So this highlights the tricky place that we are at right now. On the simpler tasks, the tasks that are just within the capabilities of the AI, within the frontier, you saw a very noticeable bump in performance. But on the more challenging tasks, if humans relied too much on the AI, they ended up making mistakes. The authors did a deeper analysis of how the people that got the more challenging task right were using LLMs. And they identified two behavior patterns. They call it the centaur pattern and the cyborg pattern. The centaurs use task delegation for their AI. They figure out which tasks the AI is better at, and they give those tasks to the AI and do the others themselves. The cyborgs, on the other hand, don't practice this kind of coarse-grained delegation. They really use the AI at a much more granular level. So I think this is the next key question to investigate. The people that are really effective at turbocharging their performance with AI assistance, what kind of behaviors are they engaging in? So overall, this paints a pretty optimistic picture for how effective AI can be in routine, everyday knowledge work tasks. And there are a few pitfalls and they need to be investigated, but the overall picture looks pretty good. So that was a quick summary. I thought this paper was really interesting. I hope you enjoyed that. If you like content like this, please like the video, consider subscribing, leave a comment, and I will see you all next time. Thank you very much.